Hi everyone, today in this video I introduce you to MATLAB programming fundamentals. So first we talked about operators in MATLAB. The first type of operators is relational operators. We have less than or equal to, greater than or equal to and not equal to. So let's look at several examples here. In the first example, we have a matrix, one-dimensional matrix, or we can say a vector, a row vector with 4 elements containing 1, 5, 4, and 2. Okay, so here we create a vector and store the vector to the variable x on the left. And then when we say x greater than 2, x greater than 2 returns a logical vector containing 0 and 1. We see 1 where the element is greater than 2, and we see 0 where the element is actually less than or equal to. If you give the logical vector to x, then for example x, and then you give it int, and int is the logical vector returned from the previous line, then it gives you the elements that are greater than 2. And these are 5 and 4. You can also give x greater than 2 directly to x. So if you write x and then and you can give it x greater than 2, the result is the same. Another way is to use a find function. The find function, for example, find x greater than 2 of the elements that are greater than 2. And as you can see, the result, which is int, contains 2 and 3, which means the element, the second and the third element. And then you can give this index vector to x like this. So you say x and give it int, then it returns the elements that are greater than 2. So actually there are two ways. The next type of operators is logical operators. We have or, and not. Now let's look at some examples. So let's say we have a vector x, and x contains 1, 5, 4, and 2. So if we say x greater than, and when you write x greater than or equal to 5, or x less than or equal to 5, then this expression returns a logical vector containing 1 and 0, and you see 1 where the element is really between 2 and 5. I'm sorry, between 2, less than or equal to 2 or greater than or equal to 5. If instead you use the AND operator, then it returns a vector, a logical vector, and you can see you have one where the elements are actually greater than or equal to 1 and less than or equal to 3, and 0 otherwise. This page shows you a list of operators. There are addition, subtraction, element-wise multiplication. So with this element-wise multiplication, when you multiply two matrices, you actually multiply element to element, and you may notice that there is a dot in front of the multiplication sign. So next is the right division, and also this is element wise because you can see the dot, and then the left division, and then unary plus and minus. The colon operator is used to create arrays. Element wise power, transpose, and complex conjugate transpose. So if the elements are real, then it doesn't matter if you use the dot transpose or the complex conjugate transpose. But if you have complex elements, then using the complex conjugate transpose, it gives you the conjugate elements. And then there are matrix multiplication, matrix right division, matrix left division, and matrix power. Matrix left division is normally used to solve simultaneous equations. Now let's take some examples. So let's say we have two vectors, two row vectors, A and B. This is how we compute the dot product. You can either use the dot function or you can do it this way. So in order to compute the dot product, we need to transpose B. So here we have A times B transposed, and that gives 12. If instead we use the element-wise multiplication, then the result is also a vector of the same size, and each element is a product of corresponding elements in A and B. So A times 1 equals 2. 2 times 1 equals 2. 3 times 2 equals 6, and 2 times 2 equals 4. Okay, for addition, it's straightforward. Here you add two vectors of the same size, and that gives a vector, of course, of the same size as well. And each element is the sum of corresponding elements in A and B. So 2 plus 1 equals 3, and 3 plus 2 equals 5, and 2 plus 2 equals 4. the sum of a vector or even a matrix and a scalar is a vector of the same size, and you sum the scalar to each element. Now we talk more about vectors, matrices, and arrays. In MATLAB, all the variables are multi-dimensional arrays. Vectors are actually one-dimensional arrays, and matrices are actually two-dimensional arrays. First, we talked about matrices. Matrices are two-dimensional, rectangular shaped data structure. Data elements can be numbers, characters, local states of true or false, or other MATLAB structure types. We use the square brackets to define matrices. Between elements on the same row, we can either use spaces or comma. When you want to separate to the next row, we use a semicolon. As we can see here, between elements on the same row, here we have spaces, and when we need to separate to the next row, we use a semicolon. And in the examples here, you don't see the semicolon at the end, but actually in your code you need this. The reason is I need in the examples I need to get the system response. So if you don't have the semicolon at the end of the line, then the system will reply the result. But when you write code, you actually need the semicolon. Okay. In the other example, I use the colon operator to generate a vector. So this means that we create a vector with elements. The first element is 0 and the last element is 8. And the step between elements is 2. If you want to transpose a row vector into a column vector and vice versa, we use a single quote, and this is the transpose operator. In the next example, given a matrix A, this is a 2 by 3 matrix, and if you want to reshape this matrix into a 3 by 2 matrix, then you can use the reshape function, and you say reshape A and give it the number of rows and the number of columns that you want. The function size returns the size of a matrix or an array in general. And in this case, it returns the size of the vector. So you have 2 as the number of rows and 3 as the number of columns. And this is also a vector. If you want to refer to an element, then give it the row index and the column index. So A11 would give you the element on the first row and the first column. You can use the colon operator to say either all the rows or all the columns. So here A1 colon means that give me the first row with all the columns. So the colon operator at um, the column index would say all the columns. In this example, you see the column operator at the row index. So it means that you want all the rows with the first column. So this is actually the first column. And if you want a row vector containing all the elements, then you just use the colon operator. Here we create a matrix B, and this is how we do matrix multiplication. In order to compute A times B, the number of columns in A has to be equal to the number of rows in B. And then it gives you the result. Each element is actually a sum of products of a row in A and a column in B. The first element is computed from the first row and the first column, the first row in A and the first column in B. The second element is computed from the first row and the second column, the first row in A and the second column in B. And similarly, this element is from the second row in A and the first row in B. And the last element is from the second row in A and the second row in B. There are special functions for matrices. Zeros, this function give an array with all zeros. So if you say zeros 3 3 would give a 3 by 3 matrix with all zeros. And similarly, ones and 3 3 would give a matrix with all ones. And this is a 3 by 3 matrix. And I 3 3 would give an identity matrix with all ones on the diagonal. And this is also a 3 by 3 matrix. Rand 3 3 would give a matrix of random numbers, and this is also a 3 by 3 matrix. Now we'll talk about other data structures such as cell arrays, structure arrays, categorical arrays, and tables. Cell arrays can contain data of varying types and size. In this example, we defined a cell array using curly brackets. And this cell array contains 4 elements, 4 string elements. In order to refer to an element, we use the index. So if we want to refer to the first element, we say month 1, and it returns January. And similarly, month 2 returns February. A cell array can contain different types of data. So in this example, this is a cell array and a 2 by 3 cell array. The first row contains integer. or just say number. On the second row, the first element is a string. The second element is an array, and the last element is a cell array. Next, we talked about structure arrays. A structure is a data type that groups related data using data containers called fields. Each field can contain data of any type or size. For example, a structure, namely student, can contain fields such as name, score, and grade. So in order to store a string, namely Mike Garcia, choose a field name. We write the structure, meaning we write student and then dot and then the field, and the field is name, so it is student dot name, and we store this string to it. Similarly, we store the score 93 to the field score, and the grade A minus to the grade field. And you can see the last line doesn't have the semicolon. So if we do this, then the system, I mean MATLAB, will return the result. We can also use the struct command, and in the parameters we give pairs of fields and values. So for example, the field is name, and the corresponding value is Mike Garcia. The field is score, and the corresponding value is 93. The field is grade, and the corresponding value is A minus. If you want to return the value of a field, for example, the value in name, then you write student.name, and this returns the string contained in it, and you can store this string to another variable, and similarly here. The next type we talked about is table. In a table, each variable can have different data type and size. Let's look at some example. Here we want to create a table with several columns or variables, namely age, height, width, and blood pressure. In order to do so, here we create column vectors. So we have vectors age, height, width, and blood pressure. And we can see that they all have the same size because the thing is their vectors form the table, and the table contains some rows. So each vector would have the same row at other. In order to create a table, we use this function table and give it all the variables, all the vectors. The parameter row name, these parameters specify the row names actually, and here we give it a cell array containing some last names. So when you run this, each row would have a name using people's last name. In order to add a variable to a table, you write the table variable and then the dot and then the variable name. And on the other side, you specify the vector or the value that you want to store to this variable. In order to remove a variable, you store an empty array to the variable. And this is how you can rename a variable. You store the new name and using this syntax, you type in the table name and the dot, and then properties and then dot, and then variable names, and within here you specify the old name. You use a colon operator to specify one or more variables and rows. If you want to get just a number of rows within a variable, use this syntax and use the colon operator, and here you get rows from 1 to 3. And this is how you get all the rows. Here are some other ways of creating tables. In the first way, you use the function table and then give it all the vectors. Each vector specifies a variable, and another way is to read from files using the read table function. MATLAB allows you to convert a structured array into a table. So for example, here you create a structured array and then use the function, this function, struct to table, to convert the structured array into a table. Next, we talked about categorical arrays. So categorical arrays store categorical values. So let's look at operations that are applicable to nominal type. Nominal means the values have no orders. So first we load using this syntax. We load the built-in dataset feature iris, the built-in dataset in MATLAB, and then convert the dataset type into nominal using the nominal function. Then this function get levels returns the levels or the categories. So if you run this in MATLAB, then you get 3 levels or 3 categories: Setosa, versicolor, and virginica. To add levels, you use the add level function, and the levels that you want to add in would be the second parameter specified by this cell array. For dropping levels, you use the drop levels function. Drop levels and give it spaces will drop unused levels, and if you want to specify the levels to be dropped, then specify it as a second parameter. The second type of categorical arrays is ordinal. So ordinal means the values have orders. It's like we talked about grades. So A plus is greater than A, and greater than B plus, and greater than B, and etc. etc. In the example, we load a built-in dataset, exam grades. If you look at the variable grades, you will see the scores of several subjects, and then the ordinal function assign different bins between 60 and 70, 70 and 80, 80 and 90, etc. etc. Different grades, for example, C, D, C, B, A plus. And then similarly, you can get all the levels or all the categories in the variable ladder using the get levels function. This is how you can add levels to any ordinal array. The first line store this string or this grade to elements that are actually undefined, and the second add a new level, which is F. Levels can be reordered using the reorder levels, and can be dropped using drop levels, and this is similar as the nominal arrays. Next, we talked about control structures. The syntax of the if structure is if the condition is true, then do something, and if you start with if, then you end with end. This is one of the syntaxes. In this syntax, you only consider doing something if the condition is true. If the condition is false instead, then you don't do anything. That is the first syntax. In the second syntax, you consider both when the condition is true and also when the condition is false, which is in the else branch. So else meaning when the condition is false, then you can do something else here. Some other code can be executed here. And the third syntax. In the third syntax, you consider several conditions. So if the condition 1 is true, then do something. And else if, meaning if the condition 1 is not true, then check condition 2. If the condition true is true, then do something else, etc., etc. You can have multiple else if, and at the end, if you want to consider the case in which all the conditions above are not true, then you have the else keyword here, and else then you do something else. The switch structure is also a branching structure, just like if. So switch compare a switch expression to each case expression, and if the switch expression is equal to the case expression, then run some statements. Otherwise, check the next case expression. If it's true, then run some other statements, etc., etc. You may have multiple case branches, and at the end you have otherwise. So otherwise, run some other statements. So this is an example, a simple example. So input function asks the user to type some numbers. So the number is stored in key, and then CLC clears the screen, and then you have the switch structure. Switch compare true to key greater than 0. So if it checks if key greater than 0 is true or not, right? If it's true, then display this string, this message. You type a positive number, and if key less than 0 is true, then display something else. And if key is equal to 0, then display you typed 0. The for loop structure is normally used when you know how many times you need to loop. So the syntax is like this: for k equal to each element in this array, then run the statements. Okay, this is an example, a simple example. You clear the screen and store 10 to the variable n, and then for I from 1 to n, display this. So you use this function num_to_string in order to convert a number into a string, and then concatenate the string to another string containing the value of I is. So what you see later on would be something like this: the value of I is 1, the value of I is 2, etc., etc. The while loop structure has this syntax. So while the expression is true, then run the statements. This is an example of a while loop. So I is assigned to 100 and prod is assigned to 1, and while I is greater than 0, then plot times I, you get the value, you get the result, and then store the result into plot again, and reduce I by 2, and do this again and again as long as I is greater than 0. So the result would be something like 100, right, times 99 times 98, etc., etc., times 2. Now we talked about functions in MATLAB. This is the syntax of user-defined functions. So you have the function name and input variables. The result is stored in the output variable. You may have multiple or more than one output variables. And the first keyword is function. So this is an example. You have an user-defined function. The name of the function is squared, and it takes one input and returns one output. So what it get would be x times x, and that is returned into y. When you call the function, you just call using the function name. So square of x and square of y. So x squared plus y squared, and the result is stored in fx. This is syntax for multiple output variables, and this is an example. This function returns both x and y. So when you call the function, you will specify both x and y. For example, when you call square and you want to get both x and y, you would do this: x, comma, y in square brackets, and square, for example, 2, right? The input variable is 2, and it returns both x, which is 2, and y, which is x squared. Now we talked a little bit about the graphics in MATLAB. In this example, I create a vector x with values from 0 to 2 pi, and the step is pi divided by 100. So x x contains the values on the horizontal axis, and then you call the function sine and give it x to compute sine of x, and the result is stored in y. And then you plot what? You plot y against x. You can give it a label using x label and y label. So x label is x, and y label is sine of x, and also the title and the font size. If you want to plot multiple series, for example, y, y2, and y3, and the way to do to plot multiple series on all together would be like this. So you still use the plot function and then followed by the list of parameters. So the parameters go in pair: x, y, meaning plot y against x, plot y2 against x, and plot y3 against x. And what we have is this. So y1, y2, and y3 have different colors. Another way is to use hold on and hold off. So after plotting y against x with blue color, you say hold on. So meaning that all the next plot would be on the same figure. So you plot y2 against x using green color, and then y3 against x as well, but using red color. You also similarly give it a x and y labels and the title, and at the end you say hold up, and the result would be the same like this with different colors. If you want to plot multiple plots all together but separately, all together in one plot but separately in different subplots. So for example, you want to plot y2, y3, and y4. So basically we need 4 plots. So with 4 plotting, you say subplot. So for example, subplot 2, 2, 1. So this means that with 2 figures in rows and 2 figures in column, plot on the first figure, right? On the first figure, which is this one. So the next plot function will plot within this figure. Similarly, the second subplot and plot functions plot in the second figure, etc., etc. Next, we talked about file access in MATLAB. So first, in order to open a file, use fopen. Use this function fopen, and you specify the file name as well as the permission. So if you want to open the file to write, then use W. If you want to open the file to read data from it, use R. And if you want to open the file to append data to it, use A. And then return the file ID back into this variable. And you use this syntax for text files. In order to write to files, use fprintf, and of course you need the file ID, which were from here, and the format and the data that you want to write to the file. So on the right, we have the list of the formats. The percentage S is to specify strings. The percentage F is to specify fixed point notation. Percentage E is for exponential notation, and the percentage D is for decimal notation. In order to read from files, use fscanf, and you give it the file ID and the format. The data is read into a variable on the left. You open a file, you need to close the file. So you close the files using fclose and give it the file ID. So this is an example. You create a vector x with values from 0 to 1 with step 0.1. And the matrix A containing x on the first row and exponential x on the second row. And then you open a file, namely exp.txt, and you open to write, and you write data in A to the file using fprintf. It takes the file ID and the format. So you want to print x on the first column and expx on the second column, and they are strings, so you use the format percentage 6s and 12s. S is for strings, and 6 and 12 are the number of positions. And after printing the first line with let's say the headers, you print to the file. You print what? You print A. You print the matrix A with this format. You will print real numbers, and then after printing, you close the file using fclose. So if you work on a project from day to day, and the next day you want to restore whatever you have in the workspace, so you may want to do this. So every day you want to save your work into a file specified by a file name. Then you say save file name. So save file name will store everything you have in the workspace to a file, namely file name, and the extension is mat. You can also select what you want to store, let's say the variables x, y, and z. And the next day you want to load all the data back into the workspace. You say load file name, and you can also specify what you want to load using the second syntax, and here you specify the variables that you want to load. So this is just some example. Basically you have A B, and C in the workspace. And then at the end of the day, you say save my data dot dat or just my data. If you say my data, then the file extension is mat, M-A-T, and otherwise you can also specify the file extension. And then when you want to load the data back into the workspace, say load and then the file name. For image files, you use imread and give it the file name. So imread read the file, the content of the file into a variable. So normally this is an array that looks like this. Basically, you have three matrices superimposed on each other. Each specifies a color. So one is red, another is green, and another is blue. So basically, this is an M by N by 3 array. And after editing the files, you want to write the data or the image back into the file specified by the file name. You use this syntax: write back A into the file here. And if you want to display an image, there are several functions. So using images is a good way to practice MATLAB. In this example, you read a JPEG file into the variable A, and then you start copying A into B. So you copy the first plane or the first matrix or the red matrix from A to B, the second matrix, which is the green matrix, from A to B. But for the third matrix, what you have in B is all zeros, So basically this is like you clear out the last dimension, so there is no blue color. You see this in the original image. You have the blue car, but after running the code, what you see here is actually have no green, have no blue color. You can read data from a CSV file. So CSV files are actually just text files and delimited by commas. So you can use either ways, either CSV read or DML read. If you use DML read, you have to give it the delimiter, in this case the comma. On the other side, when you want to write to a CSV file, use CSV write, and similarly you can also use DML write, and you give it the comma as the delimiter. So write to what? Write to this file. Write what? Write the variable m. And DML read and DML write can be used for other delimiters and file types. For now, you should need to know fwrite and fread for writing and reading binary files. For Excel files, use XLS write, and this is to write to Excel files. Write to this file, write what? Write the content of M. And when you read using XLS read. You can also specify which sheet you want to read from. You can also read from a web address using URL read. And for example, if you give it www.yukon.edu, then the result which is stored in S here would be this web page. MATLAB has many more other functions that we will see in details when you do practice and homework. So after listening to this lecture, I want you to start MATLAB and copy the code from the lectures or simple code and try yourself run the code in MATLAB and see what the system returns to you. Try to change the parameters this way or the other way, thing like that, and see how it works. And we will write more sophisticated programs later. For now, happy coding, and I'll talk with you in the next video.